Hello, this is tutorial number 1 for visual analysis. In this tutorial, we're going to model a 3-span continuous beam subjected to a uniformly distributed load. So this is the main window for visual analysis. Hopefully by now you've installed this onto your computers and have gone through some of the basic videos that IES has to offer in their support section of their webpage. And you already have an idea of how the software is laid out. But just in case, this is the main window when you start up visual analysis, and up here at the top you have the ribbon and a series of menu items. So the ribbon is context sensitive. If you click home, you get one set of buttons. If you click structure, you get a set of buttons that are there to help you define the structure that you're modeling, the loading, and then some miscellaneous tools, etc. So we'll start off using the home ribbon. Over here on the left we have the project manager. And this is where you control a lot of the details associated with your model. If you're familiar with Revit, then the feel of visual analysis is similar to that in that you have, I forget what it's called in Revit, but this is where you control all the details of the objects in your building information model. So it's very dense. It has a lot of different information in here. And when you select different objects in the main working window, then you get different behavior out of the project manager. So let me switch to a different instance of visual analysis. Here's one with a model that I've already created. So for example, if we go over here in the right and we select a member, then we get a series of options that correspond to a member. If we go over here to the right and select a node, then we get a series of options that correspond to that node. All right. Okay, then this is the main working window over here, and it has a number of different tabs. The first one is the modeling view, where we construct our model. Then after we have the model and we're ready to do the analysis, we click on the results tab. Then we can look at some design checks using AISC specs or ACI specs. And then we can generate reports as well. And then down here at the bottom, we have the find tool, which helps us with larger models to find particular nodes or particular members or things of that nature. So the project manager and the find windows are dockable, so you can minimize them, you can pin them, you can undock them and move them around to different windows if you want to. All right, so I'm going to illustrate a method here of selecting things. In visual analysis, you can drag a window by holding down the shift key and then dragging from left to right. And when you do that, everything that's inside the window that you dragged is selected. Let me go ahead and hit escape. If you do the same thing, but instead hold down the shift key and drag from right to left instead of dragging from left to right, then everything that's inside the window and everything that's intersected by the bounds of the window is selected. This is very useful if you want to be very strategic in picking different parts. Like if I just want to pick one member or maybe the members in one story of my structure, I can drag from right to left and drag a very narrow window that intersects those members, and then I just selected those. So that's very handy. It works the same in SAP as well. When we get to SAP 2000, one difference is that in SAP you don't have to hold down the shift key to drag a window. All right, so I'm going to Alt Tab back to this, and then I'm going to switch over to the window with the project description. Okay, so here's the tutorial window. You guys probably have this printed out or maybe on the screen in front of you as a PDF or whatever suits you. So basically it's a 3-span continuous beam. It has end spans of 60 feet, a center span of 75 feet, and it's made up of a W36 by 231. If you guys have had bridge engineering with me last year, then you're familiar with this bridge. I called it the Indian River Bridge at that point. If you're planning to take bridge engineering, then you'll be a step ahead of your peers when you get to that this coming spring semester. Anyways, we just want to create a beam model, put a distributed load on it, and we want to figure out what the shear force and the bending moment diagrams look like, report the maximum shear force and bending moments, and determine the deflections. So, like it says right here, the first thing I'm going to do is start a new project. Okay, so now we'll go back over to the main working window. The first thing I'll do is select my project units. Project units can be indicated by going up here on the title bar. There's a drop-down menu there that you can use, or you can go to Manage Units on the ribbon when the Home menu is selected. And so if we do that, you can get an idea of all the different options that are available to you. One of the things that VisualAnalysis does very well is it handles units very well. It probably does so even better than SAP 2000. Because VisualAnalysis does a good job of knowing when you want to use feet and when you want to use inches. For example, you can define the member length in units of feet, but when it reports stress, it will give you the stress in terms of pounds per square inch instead of pounds per square foot. Not all programs are that clever. So it does a good job with that. So kudos there. So that's the first thing we'll do. The second thing we'll do is we'll define our model so that it's set up as a plane frame. By default, it's set up to model space frames, and while that's great, most of what we do is going to be plane frame modeling, at least at the beginning. So we're going to go over here to the Project Manager under the Modify tab, and under the Project Settings, we're going to select Plane Frame. Now at this point, you also have the option of defining which axis is the gravity axis or the vertical axis and which one is the north axis. We're just going to leave the defaults in place right now. So by default, VisualAnalysis thinks that the negative y direction is the direction that gravity acts. Now that's different in different programs. SAP says that the negative z direction is the gravity axis. So you have to look that up and be aware of that when you start using a new program. Okay, the next thing we'll do is modify our grid. If we were clever here, we could see that the grid only extends to positive x equals 50 feet. I want to define the origin of the model such that point A is at 0, 0. So the point A of the beam, the left support, is at the origin. And if we do that, the beam will run off the edge of the grid. So we're going to redefine the grid to start off with. So we go to the Grid tab under the Project Manager, and instead of using a grid spacing at 2 feet by 2 feet, I'm going to use 5 feet by 5 feet. Also note that you can type in units in here as well. If you want to type in 5 feet instead of 60 inches, it'll do the math for you. I think it'll even let you use a caret there instead, and it will change the units for you. So it does pretty good there. Also, I'm going to change the number of x divisions such that we have, let's see, 41 in the x direction, and I'll use 10 in the y direction. And then I'll put the x location of the grid. If you take the total length of the girder, 195 feet divided by 2, that equals 97.5 feet. And that puts the origin at the left edge of the grid. So now if we zoom out a little bit, use the wheel to zoom out. You press down on the wheel and you can pan around. That kind of gives us our grid defined like that. Makes it look nice. Okay, truth be told, I'm not as fussy with the grid as that. I usually just define a really big grid so that there's enough room. I don't necessarily try to center the model. It really has no bearing on the analysis. It just gives you a nice working space, much like centering a drawing in AutoCAD or in, if you do some drawings by hand. Okay, so that takes us over here. We just did step 1C. We modified our grid. There's the grid location. Now I'm going to go to step 2, which is actually defining the model. So we're going to draw the members, and in order to do that, we go to the Structure tab and we select the Draw Members button. You can see by default here on my screen that the Draw Nothing button is selected, and sometimes that happens, and when I don't mean it to, and then I try and draw a member and nothing comes out, and it takes me a minute or two to figure out why. But select the Draw Members. So the way you draw a member on here is really intuitive. You just click at the starting point and drag a line and then let up when you get to the ending point. So I'm going to start here at the origin, click down on the mouse button and drag to the left. Now at the same time, I'm watching the lower right-hand corner of the screen and I can see the coordinates of my cursor. So right now I'm at x equals 60 and y equals 0. I know that that is the location of point B. So I'm going to let up there, and that creates the first member. So now I have the first element, the first member of the model drawn from point A to point B on the model. I'll do the same thing. I'll start at that point B at x equals 60. And if I take 60 plus 75, that gives me, let's see, 135 is where I want to go. So I go to x equals 135 like that. That is the second member. And then if I go from that point another 60 feet, I get to 190 feet. Okay, so I have all three members drawn. And you can see that as we do that, the find tool started to populate at the bottom. We have a table of member information. We have a table of node information. Okay, so that's going to get more and more densely populated with information as we continue to define our model. All right, now when we drew the members, VisualAnalysis just made an assumption as to what the member properties were. In this case, for me, it thought that I was probably going to use a W21 by 44, and I suspect that it selected that member size because I was working with a 21 by 44 at some point in the past, maybe with that other model that I showed you earlier in the video. We need to modify that so that we have the members defined as W36 by 231s. So what I'm going to do is hold down the Shift key, drag a window to select all three members, and then I'm going to modify the section properties. So I go over here to the project manager, and you'll note that I don't have any member information. And that's because when I drew that window or dragged that window to select the members, I also selected the nodes in the model. And VisualAnalysis guessed that I wanted to modify the nodes, which is not strictly true. I really wanted to modify the members, but here I can go down now under the Modify tab, under the Modify heading, and I can select three members and modify the properties of those as opposed to the four nodes. You can also modify the project settings at this point if you want to, but really it's the members that I want to change. So under shape, I want to change that. I still want to use a database shape, but I don't want to use a 21 by 44. So I'll click this button and find the W shapes, and then find the W36 by 231. So that's right there. It gives me the section properties that it's going to use for that. I'm fairly confident that it's correct, so I'm just going to hit OK. So now you can see that all three members are defined using a 26 by 31. Now, in my model, the member section definitions is showing automatically. You can adjust that by going to the project manager and going to the model filter. And under member details, you can turn that on or off. So I can put the shape off like that, put the shape on. I can display the member names if I want to. So the filter gives you a lot of options. You can also display the nodes. I can put the node names on there. So it automatically labeled the nodes 1, 2, 3, and 4 as I created the members. Now, I should also mention that it pays to be consistent when you draw your models. Because when you output the results, particularly for larger models, it sometimes is challenging to track the results back to the actual elements in the model. So I try to draw all of my members that are horizontal. I try and draw them from left to right. And anything that is not horizontal, any diagonal members or vertical members, I try and draw them from the bottom to the top. That way, if I look at tabular output from the software, I'll know that the first end of my element is the left end or the bottom end, and I know that the second end of the element is the right end or the top. That's just my my own notation, my own mode of operation, whatever. Let's see. I'll also say here that you can also change the names of the nodes if you want to. So you can go in here and I can change node 1 and call it point A. So it matches the definition of my problem that's in the Word document. And you can change the names of the beams if you want to as well. SAP by default thought that this was a beam because it's a horizontal element. So it called it BM and then some number. If I drew a vertical element, it would probably call it a column, a COL. If I drew a diagonal element, it might call it a brace. Okay, that all being said, let's go ahead and get back to the next step in our model. Let's see, we'll go to step C. We just did that. All right, step 3, we're going to set the joint restraints. So right now, this beam is just floating around in a hypothetical space. It isn't restrained to the ground at all. So we need to add joint restraints, not to be confused with joint constraints or member releases. These are joint restraints, which are basically the reactions for the beam, reactions for the girder. So we want a roller at point A. No, I said that wrong. We want a pin at point A, and we want rollers at the other nodes. So I'm going to select, hold down the Shift key, drag a window, select point A, node 1, and under the support type, I'm going to go in and click dx and dy. So it restrains the x degree of freedom, translation in the x direction. It restrains degree of freedom, translation in the y direction, but it does not restrain the rotational degree of freedom at that point. RZ is the rotation about a z-axis through that point. So that gives me the equivalent of a pinned support. Now I'll drag a window and select the other 3 nodes, and I'm just going to select dy for those, and that gives me the equivalent of a roller support, a horizontal roller, meaning that I'm restraining vertical displacements, but I'm allowing those points to move left and right or to rotate as they need to. Okay, so that concludes step number 3. So now we go to step number 4, and we're going to start the process of adding loads to the model. So a logical point to go would be to go to the loading menu and change the ribbon. So VisualAnalysis, like most modern software, is able to handle different load patterns and different load cases and combinations. So we have to be specific when we enter our loads in. Let me just take a second here. I'm going to clean up my view a little bit. Let me go home, zoom all. That zooms in a little bit. Go to the model filter. I'm going to get rid of the member names, the member shapes, and the nodal details. Okay, there we go. Now I'll go back to the loading tab. Now what I'm going to do is go here, and I'm going to edit the load case. Now I have dead load as my service case that's selected, and I'm editing that service case. So load source is dead. It lets you define that. That's not working. You can change in another window, you can change and select the load sources: live load, snow load, rain load, wind load, etc. Right now, I'm going to turn off the automatic self-weight. So most of these software packages will automatically calculate or include the self-weight of the members in the analysis, but I don't like to do that. Personally, I like to add the self-weight as an applied load. And we're given a load of 1,450 pounds per linear foot, and in my calculations, I included the self-weight of the 231 pounds per foot in that number. So I'm going to select that and turn that off. I'm also going to select here, right now I don't want that in a building combination. Doesn't really make too much difference. Your model should run just fine if that's in there, but I'm going to turn that off for right now. But I do want to include it in my analysis. Okay, I'll click OK there. Then the next step, step 4B, let's go over here and scroll down there. I'm going to actually apply a member load. So I'm going to select all 3 members. The load's the same on all 3 members. Go up here to the loading ribbon, select the button for apply member load. I want to apply it to the dead load case. I want it to be a uniform load. I want it to be a force in the Y direction. And I want it to have a magnitude of minus 1.45 kips per foot. Now you can change the units here if you wanted to. This would work if we want to do that. We could also type in minus 1,450, and I think if I type in PLF, no, I didn't catch that. Let's see. No, all right, so I didn't quite get, I was wrong on that. There are the units that we can type in. So I can type in pound per foot if I want to. It's not clever enough to know what PLF is. There we go. And then it automatically changes it to our working units. And we want that on the full span. It's going to be on 3 different members. The member lengths are between 60 and 75 feet. So the negative sign in here indicates that the load is in the negative Y direction. So that's important. So I hit OK, and what you'll see is the load is represented on my members like that. Okay, so we've done everything that we needed to. We've defined the model geometry. We've defined the section properties for the members. We've assigned joint restraints, so the model isn't just floating around in space, and we've defined our loading. So we should be good to do our analysis, and we run the analysis by hitting the Results tab in the main window. So I'll do that. And what pops up is the deformed shape of the beam under the load. In this case, we only have one load defined. It's dead load D. But if we had multiple loads, we could select this and it would tell us which load it's showing the deformed shape for. Up here is a status window. It tells us some information about how the analysis was performed and whether everything worked out the way that it should have or not. Occasionally you'll screw something up, you'll forget to define something, or you'll have an instability of some sort, and it'll give you an error message here, and it tries to guide you towards what it thinks is wrong with your analysis. All right, so I'll just close that back up. So there's the deformed shape. Over here in the results, you can do a lot with the results or with the results filter. So if we want to, we can show the results types. We can do a contour of displacements in the y directions, for example. So the color of the beam here shows us the magnitude of displacement, where 0 is red and blue is negative 48.48 inches. All right, we could also do a contour of moment in the z about the z-axis, and we can do a lot of other things as well. But this isn't really as useful as just a conventional shear force or bending moment diagram. So what I'm going to do is I'm going to drag a window here and select all three members and go to the member graph, and this gives us the shear force and the bending moment diagram. Actually, it gives us the displaced shape, the shear force diagram, and the bending moment diagram. So it doesn't show any data points by default, at least not on mine, but I can annotate that if I want to by hitting the annotations button over here. And that gives us all of the important points, or at least the points that visual analysis thinks are important. So let's see, I'll get rid of that window. You can see the deformed shape, the annotated shear force diagram, and the annotated bending moment diagram. All right, so this all looks pretty good. What if we wanted the reactions for our structure? We can go back to the results view here. For the results that I want, I could go back to the results filter, nodal reactions. I could show those. It shows them on the deformed structure. I can overlay them on the undeformed structure if I want to instead. And then there's some other reporting options here. We could go to a design view, and this tells us, would normally tell us whether our member is satisfactory or whether it's going to be overstressed or overloaded. But we don't have enough information in the model yet. We only have dead load. We haven't defined a live load or anything else. And then you can also generate some reports. That's a rather cumbersome process, and we'll get into that later in the semester. All right, so at this point, what I would do is, I need to select all the members before I go in there. So if I select all the members like that, try again. There we go. Go to member graph, and then I would pick these values off and report those. All right, so that represents the end of this tutorial. Talk to you again soon.